Hi everyone! Welcome back. Today we're going to be doing a bunch of integration by parts problems, and the first one that we're going to look at today is x cubed times ln, or the natural log of x dx. And the formula that we're going to be using, let's go ahead and put it over here, is integral of u dv equals u v minus the integral of v du. So this is the formula for integration by parts problems, and all this means is this part here, the left side of the equation, is our original function, so this is representing this over here. So the first thing that we have to do is assign u and dv to various parts of our problem. Once we do that, we can find du and v, and then get this part of the equation over here, and then hopefully integrate something simpler and solve. So let's go ahead and try this as an example so that we can see what we're talking about. So the first thing we have to do is assign u to one of these terms and dv to another. So we're looking at x cubed and natural log of x. One of these is going to be u, and one of them is going to be dv. And the way I like to pick is try to identify something that will become simpler when you take its derivative, because for u. Because what we're going to do is we're going to pick something for u, and then we're going to take the derivative of it, and that's going to become du. And when we plug it back in, when we plug du back in over here, we want whatever's inside this integral to be simpler than whatever we have now. So if we pick something for u that's going to simplify when we take the derivative, we're going to end up in good shape. So, for example, if we assigned u to x cubed, we would take the derivative and we'd get 3x squared, which isn't really simpler in any way. I don't think it's not apparent that it's much simpler than x cubed. On the other hand, if we decided that u was going to be natural log of x, we take the derivative of that and get 1 over x, which gets rid of the ln, the natural log, from the problem, and we end up with just 1 over x, which to me seems like it might be something much simpler. So that's going to be my first guess. I'm gonna go ahead and assign u to natural log of x, go with it and see how it goes. If you're wrong, you can always start over and flip u and dv. So I've decided that natural log of x is going to be u. So I go ahead and say u equals ln of x. Then, since this is u, the other part, x to the third, has to be dv. So I go ahead and write that right here, and you'll see why in a second. dv is going to be x cubed. So you just assign these two values. Then you need to find du by taking the derivative of u, and v by taking the antiderivative of dv. So this is going to go in this direction, derivative, and this is going to go in this direction, integral. So let's do these one at a time. The derivative of natural log of x is 1 over x, and that's just a rule. That's something that you're best off memorizing. The derivative of ln of x is always 1 over x, so that's a given. So we took the derivative. Then dv is x to the third, so we go ahead and take the integral, or the antiderivative, of x to the third. So we go ahead and write x, and remember we add 1 to the exponent when we're taking the antiderivative. So 3 plus 1 is 4, so the exponent is 4. And then we do the coefficient, which right here is an implied 1. We do 1 divided by the new exponent, which is 4. So that is the antiderivative. 1/4 x to the fourth is the antiderivative of x cubed. So now we have u, du, v, and dv, which are the 4 values that we want. That's the first step. The second step, now that we have these 4, is plugging these into this part of the formula here. So let's go ahead and do that. We have u first. So u we said was ln of x. So I'm going to write these in parentheses so it's really clear. So there's u. Then we need v. So v we said was 1/4 x to the 4th. 1/4 x to the 4th. Then we have a minus sign, so minus, and then the integral of v. So here we've got v, 1/4 x to the 4, and then du, which we got here. Du is 1/x. So let's go ahead and put that in parentheses so we can differentiate. And then we always go ahead and add a dx here, just because it's notation. You always have to have a dx here that goes with the integral sign. So this and this are the notation that tell us to take the integral or antiderivative here. So we've plugged in all of our components to the formula. Now all we need to do is simplify and solve. So I'm going to do one simplification step down here. This should simplify. 1/4 comes out in front. We also bring the x to the 4th out in front, and then we write natural log of x last. So that's done. This part is done. We're good here. Now we subtract this part. To save some space, I'm going to go ahead and simplify in place here. This part, we've got x to the 4th on the top in the numerator and x on the bottom in the denominator. So that is actually going to, we can take this part out, and this whole thing is going to become x to the 3rd because one of those x's is going to cancel, right? So we have 1/4 x to the 3rd. Additionally, this 1/4 here is a constant. So to make things simpler for us, we can actually bring that out in front of the integral. When you have a coefficient like that, you can always bring it out in front. So I'm going to say, I'm going to change this, change that order there. So I brought the 1/4 out in front. So now all we're looking at is the integral of x cubed, which is much simpler than x cubed natural log of x. So this is something that we can actually deal with. So I'm going to write the 1/4 down here, which is out in front. And then because we're taking the integral here, and this is kind of outside of the integral, I'm just going to draw a big parentheses because the whole integral of this part is going to need to be multiplied by 1/4. So all we need to do here is what we did up here to take v. We write our x, we add 1 to the exponent, 3 plus 1 is 4. The coefficient on x here implied is 1, and we divide the coefficient by the new exponent, which is 4. So we have 1/4. So there's the integral, and then always remember, of course, whenever you take an integral, you have to add c to account for the constant. So the only thing we have left to do here is simplify. I'm just going to multiply these guys out. So the final answer, I'm going to write this term as is. It's 1/4 x to the 4 natural log of x, x to the 4 natural log of x. And in this part we have 1/4 times 1/4 is 1/16. So minus 1/16 x to the 4th plus c. And that is actually going to be our final answer. And just as a quick note, in case you want to, some professors may ask you to, you can, if you needed to, factor this. You could pull out a 1/4 and an x to the 4th, and that answer would just look like this. You'd have 1/4 x to the 4th, and this part would go away, so you'd multiply by natural log of x minus 1/4 plus c. So this is your answer if you factor out the 1/4 x to the 4th. So either of these, they're both the same thing. Either of them works, they're both correct, and those are our final answers.